Welcome. To start this stream, I thought today I'd give a little bit of a background. First of all, this is President's Day weekend 2024, and a long time ago, back in 1974, the magazine Practical Television, or Television Servicing, this is from the World Radio History.com site. In 1974, July, they provided a circuit for the first type of video game, which was the Pong or teletennis. So this, I think 73 was when the first Pong video game was invented. Also, I think it was Magnavox also did one. I can't remember exactly the history on the first video game. But anyway, this magazine published an article about how to make something like this, and I tried to build it, or I built something similar to it. As usual, I didn't necessarily have all the components, but I was able to do something very similar. And then later on that year, I modified the circuit so that instead of displaying this type of game, it had some line and frame counters. And what it did was basically I had a Signetics 2650 microcontroller with 1K memory, and I used this original article as a starting point and built myself my first video terminal based on the Signetics 2650. I said it was terminal, it wasn't terminal. I mean, it was just a computer memory being displayed on the screen. So that was in 1974 or 5. I can't remember exact. Must have been 75. I did the TV version, the computer display. Anyway, so that's some of the history. So from 1974, and obviously this is 2024. So this is a project which was sort of prompted by this, finding this article, and here it is. So what I'm going to do is show you scene 3. Okay, there we go. So what I did was I took some existing HDMI to AV converter box, which I had used when I had an old TV which didn't have an HDMI input, and I wanted to hook it up to I think it was a DVD player, but only had HDMI output. And I think I bought that from Walmart for about $30 or something like that. Also, I also have some AV to HDMI converter boxes, which take the left-right audio and the composite video and convert them to HDMI. Again, that was more for just converting to HDMI, basically, from AV. So that was, again, it's about $35 from Walmart. It's just amazing the technology you can get nowadays. So what I did originally was just connect the wrong display. I just connected the HDMI to AV to the AV to HDMI, and so it got a sort of down converted to 720p, or even obviously whatever the 525 NTSC standard is. So the idea was to provide just like a low-res video converter functionality, which is what it did really well. And then remembering about this TV game 50 years earlier, I hooked up a LM1881 sync separator so I could get the frame and line sync pulses out of the video feed, and then using a couple of diodes and some capacitors, a CR network, what I did was basically create a ramp of from each of the line and frame sync pulses. And then in the video path, I put an analog switch, 8-way analog switch, so that it's four of the signals go straight through when the C address bit is low. And so I use that to basically route when the sync pulses are there. It routes it through. C is low, and that means basically the sync pulses go straight through, and then during a period of the picture, C goes high and allows the other four inputs to be selected, which have a white level, black level, and then there's like two spare inputs which are off the video, whichever video feed you want to use. So that's the sort of basic part of the system. So it basically generates ramps at frequency of line frequency and at frame frequency, and those ramps are then used later. So let's have a quick look at the circuit. Wrong one. So here is the wired up board. This has taken 3 days to put together. I started it beginning of the President's Day weekend on the Friday evening, and it's now Monday morning, so I've been working on it for 3 days roughly, on and off. So this is the video feed in, this is the feed out, this is obviously the HDMI to AV converter box with the HDMI feed. The feed is coming from a computer, and so this is the sync separator chip just here, and so I can use the scope to show some of the signals. So this pin here is the, oops, wrong way. This is the line sync pulse. So there's the line sync pulse. This is the video. So you have the sync pulse, the front and back porches, which is, there's a color burst, and then there's the black level here. I don't know what's going below black in the middle there. That doesn't seem to make sense, but anyway, that's what I'm seeing on the scope. It might just be the way the video is being synced, whether that's causing the display to display that or the real data. So there's a number of sync pulses coming out of here. I think the frame sync, so I'll change the time base back. Sorry, that's the color burst blanking back porch signal. Because it's very slow. It's not doing anything. Okay, anyway, so this is what this chip does, sync separator, and basically there are a couple of diodes here, and these diodes are what have there's a capacitor on the end of them. So what I'll do, I'll just switch that back up to wrong way. So again, so that's what the sync pulse looks like combined. On those pulses are then used over here to generate. Right, so here is the lines, line sync pulse. It's 20 microseconds of division, so it's about 30 or so across. So basically, one end is the sync pulse, and it pulls the capacitor, shorts a capacitor. Diode pulls the capacitor to ground, and then it's charged through a resistor. Generate the ramp. This one is wrong way. This one is the frame. This one is the frame ramp. Same thing, the frame pulse, sync pulse, is used to discharge the capacitor through the diode, and the resistor pulls it back up towards 12 volts. So it's not linear because it's an exponential curve, well, yeah, inverse exponential. Was it log? One of the two. There's an analog op-amp here, and that's used to buffer some of these signals. So there it's buffering one ramp. This one is not doing anything at the moment. This one is doing something different. And then there's this one where this is buffering the frame ramp. So the buffered signals obviously make it easier to do to drive the rest of the circuitry. So this is the analog switch. On this side, these inputs are video. Go back the other way. That's the wrong way. I turn this wrong way. Right, there we go. So these four inputs on this side are selected when the C input or the address is set to 0. And so this selects this video, passes it through to the output, which is on pin 3. And the other four inputs go onto this connector, and that allows me to select a different various signals. So let's just switch over to the this one. Okay. So what we have here is this is the HDMI signal from this HDMI converter. As you can see, it notices when there's no signal, it notices. And so basically what I'm doing is, I'll just unpatch it. So if I patch in, this is the video, this is the one that's selected when there's just do that one. This input is the one that's selected when there's video, and it's not the sync. So what we can do is we can feed it a number of signals. We can feed it sort of the line ramp. That's the frame ramp. We can also feed it one copy of a slow copy of the video, and then the original copy of the video. So what I've got here is a paint program running on a computer, and it's just having a red square, red rectangle. I'll change that in a moment to show better things. But to start with, let's just play with this red rectangle. So at the moment, we're not switching the video we just got the video feed. What we can do is we can use these address pins here and we can actually then switch the video over to something else. So for instance, if I just ground it, it's pulled high, so now it's selecting the black level as an example. If I find another patch cable, none of those. I wasn't prepared to find a patch cable. No, here's a patch cable I need. So if I use the other pin, then use that, I can select the white input. So I've got black and white available to me. So that's what these pins are doing. They're just changing which input is being used when the picture is available. It's either sync pulses or the available picture. So what we'll just do is, so I have the ramp going to a number of, let's go back to scene. That doesn't help me, does it? Let's go scene, no. Yeah, keycat, okay. So let me just switch around a little bit. Keycads on here. I want to go to, okay, zoom in a bit. Okay. So what this is basically on the left-hand side are 4 voltage comparators. One pair is fed in with the vertical ramp and one's fed in with the horizontal ramp. And there's a simple resistor ladder, and what that does basically is that as the ramp starts at the bottom, at lowest value, the output from one of the comparators is low. Right? So these are open collector, so they just pulls it low, the output low. And as the waveform, the ramp passes that comparator's input, fixed input, that comparator will go high on its output, i.e. to stop shorting the output to ground. And so depending on what the other comparator is doing, the other comparator is set up so initially the output is high. So what happens is that pair of comparators, when the voltage is between the two values, basically allows the output to go high. So what this does this both on the frame and line ramps. And so the output, when you connect them all together, the output goes high, basically in the middle, defines the sort of the window in the middle of the screen where the video is being used. The outside area of that is, it's always basically selecting the sync pulses, i.e. the original video. So that basically is how we cleanly, or try to cleanly, pass the sync pulses through to the output, and then pass video through when we want to display something. So after the analog comparators, there's a couple of Schmidt triggers. They're used just to square up the value and then send it over to the C input on the switch, analog switch. And then there's another set of comparators which I haven't finished drawing yet but what they do is they do the similar thing, except that the voltages that it's comparing against are variable. So this allows a number of effects to be used. Originally the idea was to create basically a bat and 2 bats on a ball. So that would require, and so basically what happens is that each comparator, the comparator can be set up so that one turns on first, and the other one turns on second, slightly later, a slightly different voltage, and then by combining the outputs again, you get a high between the two values, and so you can use that high as either a horizontal bar or a vertical bar, and if you add the two bars together, when they're both high, you get a little rectangles type shape. So depending on the dimensions you've set up, that can be treated as a bat or a ball. So that was the basic idea. Originally, I did a slight different version where the first comparator was shorting a capacitor out, basically, and then released the capacitor once the waveform got past the voltage, and then the second comparator was just looking at that ramp. But that seemed to be prone to all sorts of issues, so I stopped that and just put in basically two values, which are like left and right or top and bottom. So let's look at what that looks like. So we can look at, so I'll just patch in. I need to close that. No, it's not you. I need to switch video feed to. It's not what I wanted either. Which scene do I want to be in? Oh, there we go. That's why I've got my mouse in the wrong screen. No, not really. So let's go back to here again. Okay, so we have the analog switch. We have 4 inputs that one of 4 inputs can be selected. We have a video feed, and we can patch the address pins and to one of several different things on this red connector, or we can say patch them to ground. So when I'm patching, I'm just patching the effect there. I can display that as that one. So this is what we're currently saying. We've got, say, the video feed is a red rectangle, and we can then switch it to various modes. So this one is wrong one. Okay, that'll do fine. That's the horizontal line. Okay, let's go back to here. So we have I have 4 controls. I have these 4 controls wired up, and by adjusting these, I need a scene, don't I? Yes, okay, let me just switch this around. We can add cam, turn on. So turn that camera on. I can just configure it. Yep, that's what I want. I want to put it at the front. No, what am I looking for? Properties. No. I want to put that to the back. Why are these upside down? Okay, this is just boring. order. There we go. Move to the bottom. Order. Move to top. There we go. I found it. So, yes, that's better. Okay, gives you some better visuals. So we have this patch panel, and I can patch in a number of different patterns, both horizontal and vertical. Too far up. So it's a horizontal area. So these two controls are top and bottom, left and right motion. There's no left and right, we've got a horizontal bar. And this is nominally a width, but the way it's miswired, so it doesn't actually handle width, it handles, it sort of makes it different. Because I make it narrow, I can, oops. Yes, there somewhere. Make it bigger. So the idea is it basically is it moves two things up and down, which is fine. So the next one long. Okay, so this is a horizontal width. So this is a width, and we have a position. It's not working very well. Okay. It's an analog system, so why wouldn't it misbehave? Oh, I know why it's so noisy. Okay, depending on what it's switching between, it can switch between these two inputs, which one of inputs not connected to anything. Duh. So we'll just wire it up to something, just in case that gets selected. Okay, so it's not that one. So we can switch, instead of using 0A, we can use B. And we can use, switch white background, there we go. I'll say it was patchable, so let's have a really wide. So what's happening here is this is not a this is only using one edge of the one comparator output. This one is this one. This is getting so confusing. I don't know why you're not. Okay, I didn't test it beforehand. So this was the up down, I thought. So one of the problems, obviously, with the capacitor-based ramp is it's an exponential curve. It flattens out because the charging rate is dependent on the voltage difference across the resistor, and the resistor, that obviously, as the capacitor charge, that goes down. Now we're using a 12-volt supply for that, but we're only using like the first 5 volts of it. So it's significantly linear compared with the full curve. But it also means that the two comparators are looking at slightly different parts of the curve at different times. That's why the width, if you notice, is not consistent, because the ramp is not linear. and I'm not going to fix the linear ramp. I could fix the linear ramp by using a constant current generator instead of the resistor. I could use a current mirror. But at this moment, for this simple weekend project, this is good enough. So anyway, so this one works a little bit better, so that is like width. And it's less, for some reason this is not as noisy as the horizontal one. See, the horizontal one is a lot noisier. Not sure why. Anyway, so it's something to do with the circuit. So the original circuit up to this point, which you can't quite see, the first comparator. Sorry, this comparator up here is the one that's doing the border. So this one is basically providing the sync pulses are always being passed through during that period, and providing basically a border. And this one is basically sort of the main functional one used to generate the different effects. So it has basically a top, bottom, left, right, effectively what the four comparators are using. So this little analog mixer on this side, the one over here, which is taking in the current four controllers. What this one does is it basically, it's a simple matrix. So one of these controls, which is a position control effectively now, it sends that voltage to both the left and the right, or the top and bottom at the same time. And then this one, which is the width or height, depending on which we're using, basically is added to only one of them. It should be added to the right and should be added to the bottom. So that basically creates a width control. So in principle, I think it works better with the horizontal left, it's adding to the wrong one. I think it's adding to left instead of right, which is why for the horizontal it does that, but it sort of moves, rather than moving, just getting wider and narrower, both edges move. So I think that's okay. It's fine. So again, there's lots of noise there. I'm not sure whether all that noise is coming from. I know where some of it's coming from. So what I did do was I added a way of mixing in an audio signal. And let's see if we can find that on this system. So we'll go... and where is it? That's what I did. You can see it over there. Okay. So what we have here is now we have the audio is basically being mixed in with the position. So the width should stay roughly the same, and it's just the I'll turn off that bit. I didn't mean that one. That one I'll turn that off. Let's switch to... So what we have here is we basically have a typical oscilloscope style. So we basically moving the position of the bar, and we can just play with it. Obviously that's the triangle wave. Wrong one, it's on this one. We have basically the saw. Let's just change the frequency up a little bit, up an octave. Then fine tune it. Too loud. Bring the volume down on the mixer. So I'm using one of the outputs of my Zoom mixer, I have an L20 which has 6 different outputs, 6 audio buses, and that's feeding into a jack socket which comes over this cable here, goes to both, basically the position on the horizontal position. So if I turn the volume up and down, I can generate different things, or I can move them left, right-ish, make it narrow, wider. So what's not working? What's not working yet is I don't have a way of anding together. No, I don't yet, do I? Oh, I thought I did. Hang on. What's this one? That says horizontal bar. Okay, it's not what I wanted then. I mean, this is video, digital data. Use it because it's driving the switch. So it's not a video. So that is the. Oh yeah, that was the other thing. The gain in this part of the circuitry is not high enough to make the voltage go high enough to go to the bottom of the screen, which is why it sort of gets stuck halfway. That was just a bug. So what I should do is change the video feed to something else, because it's more interesting as live video. Okay, let me see if I can find the find a video feed on the other computer. So let's just move the mouse over. And you get another keyboard out. Anyway, we'll just move it over on the. Which screen? No, wrong computer. That's the computer I'm looking for. Where is it? So what I want to do here is I had paint running, which is this screen. Oh, it's on the other monitor, of course, yes. So we'll do is bring up. And go to YouTube. Yeah. I know. I don't care. I've got the antivirus turned on, which is blocking Chrome updates. No, I didn't want to hit Gmail. I wanted to hit YouTube. Okay, so I won't actually play any videos, but this is good enough to show what I need, because it's just it's a background feed. Okay, so just leave that there for now. Pull that back out. So, as I said before, it's patchable, so we have the original video, which is this one. We also have the video which has been buffered through an op-amp, which is, oh, I got not showing the, wrong, okay, so let me get this right. That's on the wrong monitor. So I need to switch back to the other computer. And put it on the other monitor. sideways over here and then hit that button. There we go. I don't need paint. I think that's paint. Keep losing where the mouse is. It's there, okay. Just hit F11. Okay, there we go. Good. So anyway, so we got our video feed in the background. So this is a lower res version of the video. Now, because it's going through an op-amp, the op-amp has a phase delay. It's not a video, it's just a TL74. It's for more like for audio. And therefore the color frequencies are now shifted. So if I, as you can see, the color frequencies are all over the place. So that's what happens if you put video through a TL84 op-amp. And that's what the video looks like, straightforward. So the only thing here is the switch chip, the 4051. And that's the switching of that is generating that black line over towards the right. That's actually where it's switching between the border value and the sync value. So the sync value part is when the C input is 0 on the multiplexer chip. All 4 of those inputs are wired to the original video, which also includes the sync pulses at that point. And then there's a border generator, which is this chip up here. And what it's doing is generating the video border signal. So this is the video feed. Oh, you can't do it. Anyway, so that's the whole point of what you're seeing there. Now, what's interesting, so that's the original video, and there's a lower res version of it. Over on this side, I added another op-amp. So what this other op-amp is doing is basically it's inverting the video. And I'll put that onto, I can use that as the primary video feed instead. So here we have a negative image. I can put the regular image on the alternative. So now we have 2 of the inputs are connected to wrong one, that's fine. So what we have now basically is it's selecting between the negative image and the regular image instead of black and white. Although we can make it show black and white instead, just by using the address lines and patching it. So it's a lot of different patches you can do with a few simple bits of video. So there we switch now. So instead of using these 2 inputs, we're now using these 2 inputs, which are the black levels. So the black level is actually this. Black is this one, this control here. So that's effectively set in the black level. This other one set in the white level. So I can actually turn them up and down, so they don't have to be black and white. They're only used in video. They're only used as generated things. But they're also used... They're also used because what they do is that... Oh, missed it. Wrong one. So what they also... Oh, yeah, this one is... There's two versions of it. An inverted version of that signal. So you got that one. Oops. And that one. So these two signals are inversions of each other. There we go. So we're doing digital processing. So we're using the switch. So the switch is doing all the work. We're not generating any video. We're just generating white levels and stuff. So anyway, it's patchable. We can patch in different patches. We can do other different things. The idea originally was to a bat and ball style, but I never did quite get that to. There's some still tweaking to the hardware, but it's working well enough to show some of the features I was looking for. So we have horizontal lines. We can change how wide it is. This is wide the correct way around, so it's width and position. And this next one should be the opposite of that. I think it's not wired up yet. Okay. So there we go. That's sort of pretty much everything. So I can, because I have a mixer here, I can turn that one off and bring up the audio, so you're seeing my voice live instead of the tone from the grandmother. So what else can we do? So the next level of control is to fix the wiring for the horizontal, so it's width and position rather than it's sending the width control to the wrong one. I think that's what the problem is. Took a lot of debugging to get this hardware, so there's a lot of wires, a lot of wiring done. And I think the main thing about the wiring is that, you do wire a little bit, test, wire a little bit, test, because when there's something like a short circuit because you solder blob or you wire a couple of wires back to front. I did get one of the potentiometers to smoke because its wiper was wired to ground instead of it was wiper to ground instead of the value I meant to. I got two wires twisted. None of the chips have gone bang so far, so that's all a lot of testing there. I'm powering it with from a Eurorack system, so that's using the plus minus 12, which the op amps are using, and the plus 5, which is provided by that Eurorack. The 3 lights on the power supply monitor the power supply status, and at least once there was only 2 lights on because there was a short again, so either missed wired. Actually, there just aren't a lot of components, but there's a lot of wiring. So I'm really happy with this. So the next stage, if I say it out loud, I'll probably have to do it. So the next stage is to add an oscillator, a high frequency oscillator, make it a simple one. Use it, let it to be synced with the line sync, and then have a divider chain, so it divides it down. And what that will do is allow me to have a digital back display, background display, and by using a digital display and then selecting, working out which counts I'm interested in, it's easy to generate thin vertical lines, and then also it's easy to then also add another counter which counts the lines and is reset every frame, so I can do basically a digital background, or at least a digital horizontal and vertical lines, which for something like a bat and ball, for a bat, where the bat stays in the same vertical position, it also makes it a little bit easier. So I still plan to try to do the Pong game, or teletennis as it was called in the UK, and yeah, it's a very interesting project. So the stretch project would be to use the digital background and have, say, a number of sort of white dots, white rectangles, and then by comparing using a comparator to slice the video, we can have it so when the video is white, the comparator output is high, and then we can AND it with individually with each of the dots. So when that gives a pulse, it means that the white video part of the video is coincident with the dot. So you should be able to adjust things potentially so that you can wave a hand around in a video from a camera and basically interact with the dots. And if I can do that, I can then obviously send that to an Arduino or something and generate MIDI data. So with this analog synthesizer, it should be able to convert it into a video theremin type idea. So I should be able to play MIDI instruments at a minimum, but just by waving your hand in front of the camera. So that's the stretch goal of this project. Yeah, play Pong. Now, if I was not using analog hardware, obviously this is all very easy to do on the digital system. Video processing, I haven't tried that in JavaScript or anything like that, but it's straightforward to do in hardware. So I could generate. Can I generate? Yeah, I can see what you can't do with this analog circuitry is you can't switch between two different video feeds because there's no memory, so the video feeds would have to be synchronized. So that is so unlike what you can see on the screen here on the YouTube homepage where there's a live video, some live video and other images, you can't do that. You can't mix video without a frame store to resynchronize. And it would be nice, for instance, if these you probably can, this HDMI to AV converter. Maybe there's a hack where the sync pulses are fed into it, and it synchronizes with them instead of just generating the image itself. In that case, if you could hack one of those, then you could also use several of those and keep them synchronized. And then that would allow you to switch between multiple video feeds, different image video feeds. So there we go. It's a 3-day project over the weekend, starting from scratch, designing it, debugging, testing, making changes, and I think it's done. Yeah. Okay, time to go. I gotta get to work in 4 hours. Okay, top streaming. I gotta get the mouse back. Anyway, if you made it this far, thank you for watching.